When a modern symphony orchestra warms up, the oboe sounds a clear, pristine A, and the entire stage falls into line, tuning to exactly 440 Hz. It feels timeless, perfectly unified. But that sensation of pure, universal harmony is actually a carefully engineered illusion. That standard pitch hides a centuries-long war against a stubborn flaw in the physics of sound. This diagram illustrates the ancient Greek monochord. Pythagoras used instruments like this to demonstrate that musical intervals are governed by simple whole number mathematics. Divide a taut string exactly in half for a 2-to-1 ratio. This creates the pure octave, the cleanest sound in nature. Divide that same string into 3 equal parts, yielding a 3-to-2 ratio. This perfect fifth is the structural backbone of Western harmony. This circular diagram plots those exact ratios. Logically, stacking 12 perfect fifths should align flawlessly with 7 stacked octaves, creating a closed geometric loop. But plotting the 12th fifth overshoots the octave, leaving an inescapable mathematical surplus known as the Pythagorean comma. It proved that the universe's math does not perfectly align. For centuries, this tiny leftover fraction remained a permanent ghost in the musical machine. By the Renaissance, instrument makers were building highly complex keyboards, like this dual-manual harpsichord, designed to play those pure, whole-number mathematical chords. But tuning pure chords in one key forced the Pythagorean comma's mathematical error to accumulate. The excess fraction had to go somewhere, so it dumped itself into distant, less commonly used keys. If a musician dared to play a chord in one of those overloaded keys, the instrument produced a severe, howling dissonance. These aggressively out-of-tune clusters were so harsh that musicians named them wolf intervals. A player could coax beautiful sounds out of the instrument, but they were trapped in a musical prison, limited to composing in just a handful of safe keys. As instruments scaled up into towering pipe organs, theorists desperately searched for workarounds called temperaments, shrinking certain fifths to preserve the purity of others. The ultimate solution required a deliberate act of mathematical radicalism, equal temperament. Instead of hiding the fraction in unplayable keys, theorists proposed dividing the Pythagorean comma perfectly evenly across all 12 notes of the octave. This spacing relies on the 12th root of 2, forcing every semitone to be spaced by the exact same mathematical distance. It was an effective compromise, but it carried a strict penalty. By spreading the error everywhere, no single interval except the octave is purely tuned anymore. Every major third is slightly sharp, and every fifth is microscopically flat. Yet, this calculated imperfection achieved total creative liberation. Composers like Johann Sebastian Bach could suddenly modulate seamlessly from any key to any other key. It democratized the keyboard entirely. Equal temperament solved the mathematical layout of the keyboard, but well into the 19th century, Europe still lacked a standard starting pitch. An opera performed in Paris might sound entirely different a week later because another city tuned their instruments nearly a full semitone higher. For traveling vocalists arriving at venues like the Vienna State Opera, this shifting standard was physically devastating, routinely straining vocal cords to the breaking point. The rapid expansion of international rail travel and the rise of touring virtuosos pushed this fragmented system to its limit. In a globally connected age, localized sonic chaos became an unsustainable engineering failure. The crisis was finally resolved in the mid-20th century, driven by the intersection of acoustic science and the mass manufacturing of industrial tuning forks. Through a series of international agreements culminating in 1939, the musical world settled on a strict universal metric. The A note above middle C would vibrate at exactly 440 Hz. Today, when an orchestra begins its tuning sequence, the musicians are upholding a profound historical truce. We sacrificed the absolute natural purity of ancient Greek physics to gain infinite expressive freedom. We engineered a system where every note is slightly out of tune with nature, so that we can play perfectly in tune with each other. This was brought to you by Notes and Silences. Thank you for listening.